Hi all, this is Mr. Yeager. For this particular section, we are looking at the first way to describe or method to show how to describe motion of an object. So obviously on the last videos, we finished up basically with all the introduction to kinematics, the words that we use for kinematics in terms of displacement, velocity, and acceleration. So now we want to try to use those words, or basically how can we illustrate those motions that we're talking about, the speed up, slow down, and so forth, with basically different techniques. And so there's three techniques out there. There are motion dot diagrams, which is what this video is going to be about. There's motion graphs, which is what the next videos are going to be about. And then there's kinematic equations, all right? For regular physics, that's going to be in Unit 2. For AP Physics, that's in this Unit 1, all right? We include that in Unit 1. In regular, we kind of move that to a separate unit completely, all right? So, again, we basically are going to focus on the motion dot diagrams today. Now, before I get that, let me kind of just go through the different types of motion that are out there. And this actually we'll use for both motion diagrams and graphs, so types of motion, okay? So there's, I think, around 5 different types of motion. 4, 1, we'll figure it out, all right? 1, the first type of motion is that you are simply at rest, okay? Which obviously means you are not moving, okay? This would mean that you have a velocity that equals 0, all right? That you have no velocity. The acceleration will usually we'll say the acceleration is also 0, but as I said in the last video, the acceleration does not tell you what type of motion is occurring. It's going to tell you what will occur in just a moment, but it doesn't say exactly what is occurring at that specific time, okay? So it turns out acceleration could be positive, it could be negative, okay, or 0. But velocity will definitely be 0. The second type of motion, we call it constant speed or constant velocity. We usually like to say constant velocity. This means that you will have a positive or negative velocity, and acceleration will definitely be 0. Okay? Okay? Will definitely be 0. Okay? Excuse me. All right. So that you have a velocity, but again, positive, negative just means the direction that it's going. Okay, but that's all we're looking at. It's constant velocity. 3. Okay, for 3, you could be speeding up. All right, you could be speeding up. That's the next type of motion. Obviously, this means you're accelerating, but we want to be more specific than simply just accelerating. Speeding up means that your velocity and your acceleration have the same sign. So both of those are examples of speeding up, either positive V and positive A or negative V, negative A. They have to go together, okay? That means you're speeding up. The last one is where you are slowing down. And when you slow down, I'm going to go and put a line here so we clearly see the difference. That would mean the signs for velocity and acceleration are opposite. Signs for acceleration are, velocity and acceleration are opposite. So, when we start doing all these diagrams, what we're going to be saying is what type of motion is occurring. When we start doing the motion graphs in the next video, we're going to be saying what type of motion is occurring, what we need to think about. I'll tell you the dot diagrams are a lot easier, but we're going to be focusing on what's the velocity, what direction is the velocity, is there an acceleration? If there is an acceleration and velocity, are they the same sign or are they opposite signs? But we will only say that objects are at rest, at constant speed or velocity, speeding up or slowing down. We don't just say accelerate. We will never just say that it's accelerating. That's not enough information. All right, so here we go. So these are motion dot diagrams. These are pretty straightforward. Usually I don't have people struggle with these really almost at all in any physics class. They're pretty simple, okay? If there's anything that's simple, this would be simple, okay? So right here, basically, the whole idea of dot motion diagrams is this is a technique that's used, and usually we do a lab in it where basically somebody follows a car, and you put a dot every single second where the object is at that point in time. So basically, these dots are showing you what is happening every single second. Usually the first one, we say it's time equals 0, but then the second one would be 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, and so forth. All right? And what you're trying to see is, what are these dots doing? Okay? What are these dots doing? Are they staying an equal distance apart, which means every single time I move, every single second I move the same distance? Okay? Do they get farther apart, like that you see in B? You can see that they're getting farther and farther apart. In C, they're getting closer and closer together. All right? D, very, very slow, and then obviously speeding up. So that's what we're basically looking for. What is occurring in each of these dot motion diagrams? Okay, and I'll probably come back to this one again. So what we basically can see is if they are equal, the dots are equal distances apart, all right, we say that you are moving at a constant speed. So both of these are showing you examples of constant speed. All they're showing you is obviously the ones that are farther apart means that it's going faster, a faster constant speed. So closer together means the object's going slower. Farther apart means, obviously, again, each dot is a second. So we're saying after 1 second, this object has moved this far. After 1 second, object B has moved a lot farther. So distance over time. Again, velocity is displacement divided by time. All right? It's showing you that it is obviously moving a farther distance over time, therefore going faster. So that would be your first type of setup. Now I'm going to go ahead and just say this already. So this is showing you constant speed where they are equal distances. I'll go ahead and say, think about what would happen if you're at rest. We don't really show rest because all that would happen is you'd be at the same spot over and over and over and over and over and over and over again. Obviously, if there's only one dot, the object's not moving. So we usually don't do rest motion dot diagrams. It's going to be constant speed or speeding up and slowing down. Okay? You can see the dots get farther apart every single second. That must mean I am getting faster. You're covering a greater distance in the next second. You must be accelerating. In this way, you are accelerating with a speeding up. Okay? That's the type of acceleration. If the dots get closer together, obviously you are slowing down. Closer together. Okay? You are slowing down. All right? So, going back to my initial ones, you can obviously do a combination of them, or it could be only one type. You can see for A, equal distances, equal distances. And guys, this is not something that you need to pull a ruler out and go, let me make absolutely sure they're equal distances. It should be something that if it looks like they're equal distances, they're equal distances. They're not going to try to sit there and try to trick you saying it has a small acceleration. So A is definitely a constant speed. Okay, it's a constant speed. B, the dots are getting farther and farther and farther apart, so you are speeding up. All right. C, they look like they're farther apart initially, but they're getting closer together. You're slowing down. All right. D is a little bit strange. The idea here is you are really kind of moving slowly, so there is actually a constant speed at the beginning. But then what happens? It speeds up. So they could possibly do a combination. All right, what's happening at E? E slows down for a long period of time. I think right here they're trying to show you, hey, you are at rest because that dot's so gigantic, basically you keep on hitting the same point over and over again. So it actually slows down, comes to rest, and then speeds up again. All right, that would be the most complicated that these get, where they have a couple different versions or a couple different types of motion occurring. All right, but that's basically it. You don't need to do anything about is it positive or negative velocity or acceleration for motion dot diagrams. They are really, truly just going what is happening, what is occurring. It is possible that they could ask you to solve for a particular speed and stuff, but that's something for later on. Right now, this is just something that's more qualitative. You take a look at it and you go, what do you see happening based on these pictures? Okay, so that is it.